Okay, let's look at some very large numbers. Now, we know that 10 to the power of 3 is equal to 1 and 3 zeros. That's 1,000. In scientific notation, there are two parts. You have a numeral part. For example, in this case, it will be 1. And then you have a power of 10. So that will be 1 by 10 to the power of 3. Let's try a few of these. Okay, if I had 40,000, that's the same as 4 by 10 to the power of 1, 2, 3, 4. 10 to the power of 4. For example, 700 is going to be 7 by 10 to the power of, as there are two zeros, it's 100, 10 to the power of 2. This is scientific notation, these two values here, because we have a number which is between 1 and 10, but doesn't include 10, and we have a power of 10. A number, again, 7 is between 1 and 10, not including 10, and the 10 is to a power of 2. Okay, try a few more. So you have 6,000. That's going to be 6 by 10 to the power of 1, 2, 3. Right, okay then. 5 million. 5 by 10 to the power of 1, 2, 3, 4, 5, 6. So these are really nice scientific notation. The numbers here are nice whole numbers, 4, 7, 6, and 5. But what if you have something like this? 3,500. Okay. Well, I've got two zeros here, so I could say, well, that's the same as 35 by 10 to the 2. That's great, but this is not scientific notation. Right? Because scientific notation, the first number has to be the first part, must be a value between 1 and 10, but less than 10. The second part is the power of 10, is 10 to a power. These are the two things. So 35 by 10, I'll just do that more like that. 35 by 10 to the 2 is not scientific notation. Let's have a look at the 3,500 again. 3,500. If I want this to be a number between 1 and 10, I would have to make it 3.5. Okay, so there really is a decimal point there, but it's invisible. We don't use it. And the decimal point has moved, well, the number has been shifted across the decimal 1, 2, 3 places. So you say by 10 to the 3. Okay, what about this? 260. 260. 200, so we know it's going to be 2.6 is the number. And it's going to be 10 to the power of 1, 2. We have to move these numbers across the decimal by 2 places, so the decimal will end up here. So that's 10 to the 2. Okay, now I mean theoretically I shouldn't be saying the decimal moves, the decimal doesn't move, the number is shifted across it. But sometimes it's just easier to visualize the decimal point shifting. Okay, how about this? 4, 1, 2, 5, 0, 0. Now, that number between 1 and 10 is going to be 4.125. Now the power of 10 is going to be multiplied by 10 to the power of, after the 4 here, there are 1, 2, 3, 4, 5 digits, so it's 10 to the power of 5. How about this? 613, 000, 000, 000. That's 613 million. Okay. As a decimal or as a number between 1 and 10, this will become 6.13. That's the first part sorted. Now, if the decimal is there, that means we have 1, 2, 3, 4, 5, 6, 7, 8 powers. So it's by 10 to the power of 8. And this is how we use scientific notation to express very large numbers. I'll try another. Say I won 3,450,000 euros. That would be 3.45 and 1 after this is where we're putting a decimal, so there's going to be 1, 2, 3, 4, 5, 6 numbers after the decimal. 10 to the 6th. Okay, there's some examples of scientific notation. When the numbers are very large, then the power of 10 is positive. So when, or large, when the number is greater than 1 really, when the value of the number is greater than 1, the power, well, I'll just say greater than 10, the power is positive. When the number is 1, that's 10 to the 0, isn't it? Okay, so we've done that. Scientific notation has two parts. The first part is a number. The second part is a 10 to the power. When the power of 10 is positive, the number is greater than 1. Thank you.